Moving on to the friction versus applied force graph, that the question of the 2018 past paper says, right? So, like I said, the first thing is not to get scared and to try and check what they are trying to say here. What they are trying to say here is they have given you some data from the previous question, right? They have transferred some data from that previous experiment to this graph and trying to check if you can read this graph and understand certain information and try to answer some questions, right? So that is the main target here, or that is the objective that they have made this question, right? So let me go to the previous question. They say that okay, there's an object like this, right? So they have attached a Newton meter to this, and they are applying a force called X, right? Applied force. So they are trying to pull the object, right? So we already know that there's a force which is resisting the movement of that object, which is also called the friction, right? So the objects, they don't like to move. There's a force within, them, between those objects which are in contact with each other, opposing the movement or resisting the movement. They don't like to move, right? So to overcome that, we need to apply a force that is more than that of the force that is resisting the motion, right? So that means you have to apply a force in a different direction to get some movement. So we'll come on to Newton's first law of motion. It says that when an unbalanced force is applied, there's movement. When the forces are balanced, there's no movement. Balanced means I'm telling you equal and opposite in direction, right? So equal in magnitude or equal in the value and opposite in directions, right? So a good example will be there are two identical twins with equal height, equal weight, equal strength, equal power, equal pulling power, and we tell them to pull each other in different directions. Okay, are they supposed to move using same force? All right. So, but they're in different directions. What happens is the forces get cancelled out because they act in opposite directions, right? So there's no movement. So this is what they are trying to say here. Okay, what they have done is, this is the experiment. Like I said, what they have done here is an experiment, and they have taken data from that experiments to this graph, and they are trying to check if you can understand that experiment and the data that they have taken out from that graph. All right, so this is what they have done. If you read the question once again carefully, this is what they have done. They have attached a Newton meter, they have applied the force gradually means step by step, but gradually increasing means step by step increasing, gradually decreasing means step by step going down, right? Reducing. Okay, so they have applied a force X here and there's friction here. What they have done is they have taken it to the graph. So look at the subject of the graph. Subject of the graph is the experiment over here, the whole experiment they have done. And what are the other important points? The applied force, which is X. X is increasing. What happens when the applied force is increasing, and what happens to friction against that applied force? All right. So we know that there's a when the Newton meter is attached, when you want to pull something, okay, like this, same like that, if you made a setup like this and try to give a small force, what they have done here is that, right? And they have checked whether there's movement or not. Okay, so they have given 1 Newton and checked what has happened, right? And they have transferred those data here, right? So they have put 1 Newton, and they have also measured that there was no movement, so that means they have assumed that the friction is 1 Newton. Why? Because when there's no movement means the forces acting in opposite directions are same, right? That is why there was no movement. And then they have applied 2 Newtons and checked what has happened, right? Give me a second. Okay, then they have applied 2 Newtons and checked what has happened, and they have identified, or they have observed that there is no movement, so that they have assumed that the friction is also 2, right? Because there's no movement. When there's no movement means there's an equal and opposite force, equal force in the opposite direction, right? So, and they have applied 3 newtons and checked what has happened. Again, there was no movement, so that is why they have decided to write 3, right, in the friction side. So that means there was no movement. So now they are asking what has happened, what is the name of the frictional force when the applied force is 3 Newton, right? So then we know that the friction is also 3, but they act in opposite directions. You know that friction acts in this way and the applied force acts in this way. So this shows that friction is also 3 and the applied force is also 3. That means obviously there is no movement. Like, you know, two people pulling each other with equal force in opposite directions. There's no movement, right? So that is called static friction. Over here we have written it static friction, right? But there's another friction called limiting friction. No, the maximum friction that is applied or maximum friction that is available when the objects have just started to move, right? So this is called limiting friction. So when they ask about limiting friction, what is the limiting friction? You can go to the value. This is friction here. This is applied force. They're asking for friction. So you have to go to the value of friction here, not applied force here, right? Applied force can be different. Okay, in this case it's the same. That's a different thing, right? So, but you have to check this value over here, right? So very simple. So this is limiting friction is the maximum friction. So where the maximum friction is there is 4 Newton, right? Is at 4 Newton, right? Then we have, after the maximum friction, they have kept applying the force. You can see from here, they have not stopped there. They have kept applying force, right? Then the graph shows that the friction is not changing after a certain point. It drops slightly after a certain point. That drop, you know, is not in your syllabus. That is A-level physics, right? So you don't need to identify those and do calculations based on that. But you just need to understand that after a certain point, after this, you know, overcoming this maximum friction here, the friction has slightly dropped and it has continued in a straight line, like we learned from the previous graph. It's not changing. That means the friction is not changing. Friction is like 3 point something something, right? Slightly less than 4, but it's continuing in a flat line. That means it's not changing, but the applied force is changing. So that is called, but then we can understand that there's one force which is changing, but one is not changing. That means there's movement in that direction. Newton's law. There's movement in that direction when the forces are unbalanced. When there's force in one side, let's say the twins, you know, we call one twin to stop pulling and we tell the other twin to keep pulling, right? So then it's something like that. Or we call that one twin to pull slightly, but we call the other twin to pull more with more energy, put full power, and we tell one guy to just hold back slightly using the same power. So this is something like that. Then what happens is both the people will start moving towards the one who applied more force, right? So same like that over here also is the same. So x is increasing, that means the object has started moving in this direction, right? This direction. So this is what they are telling. So when the objects are moving, what is the name of the friction that is related to that is called dynamic friction or kinetic friction. You can use both the words, but your book says dynamic friction. I hope you understood this, right? If there's any questions, let me know. Thank you.